This week in Weekly Space News. Neptune's moon Triton has finally been mapped after 25 years. And the Jupiter moon Europa, will it be the best candidate for life beyond Earth instead of Mars? No short news this week, but the questions about life on other planets and, very interesting, about black holes. And this week's place to visit, a dark place near your own house on August 31st, or even better, in the southeast United States. This is Weekly Space News. Hello everyone, this is Frostbreath reporting and welcome back to Weekly Space News, the 4th episode already, and things and time are just flying by. I once again received a few very interesting questions which I'm going to answer for quite a long amount of time this time, because they were very good questions, so thank you so much for those. Those will be answered later on in the episode, but first the headline news. As you've heard in the intro, something special has happened after 25 years with the planet Neptune, or actually one of the moons of planet Neptune. As we all know, planet Neptune is the 8th and final planet in the solar system. Unless you consider Pluto a planet, then it will be the one before last planet. But let's actually visit Triton, the biggest moon of Neptune, which has been visited a long time ago by the one and only space probe to ever fly by Neptune and its moons, the Voyager 2. He flew by in 1989 at this planet, Neptune, and its moon Triton. And Triton is actually its biggest moon, and it's a very strange moon. Let's actually turn on orbits to see why it is such a strange moon. It seems that we have not turned on the orbits of moons, so let's actually do that. There we go. Dwarf planets off, possibly dwarf moons on, makes it a little easier to see. Alright, here we go. Zooming out. First of all, as you can see, all moons of Neptune are in a quite normal orbit around the planet. You can see those tiny orange-brown like lines. Those are orbits of the moons, dwarf moons of Neptune. But here's Triton, and what's even more strange is that if you speed up time, you'll see that it actually orbits in the opposite direction, which means it was likely an object which has been caught by Neptune's gravity, and that way it's actually orbiting the wrong way. Neptune turns, well, if you have to watch it closely, it's like counterclockwise, like most planets do, and of course all of the moons follow, but Triton does not, because it probably flew by Neptune and then was caught within the massive gravity field of this very large and heavy planet, and then flew and orbits in the opposite direction, which is very strange. What is also fascinating is that it's actually an active body, and what they mean with an active body is that there are active things on this tiny moon. In fact, there are geysers, just like the volcanoes on Jupiter's moon Io and the geysers on Enceladus, the moon of Saturn, which makes it one of the 3 active bodies in the outer solar system. Now it has been 25 years since it has been visited by the Voyager 2, but at long last scientists are able to map the surface, as you can see in this picture. Not the best resolution, because obviously it's an old probe that has flown by a long time ago, but they finally managed to map this moon. Now that's actually an interesting achievement, because it's somewhat of a test to see how this will go for the dwarf planet Pluto, which will be visited by New Horizons in July next year. So, as a test to put together 25-year-old photos, it's a great thing to check how it will work before we'll first see Pluto ever close by. Which will actually be quite interesting, as it will only, as the space probe will only have a few days to actually make pictures of Pluto, as its speed is so high and the planet is so small, it will fly by in no time. And this week's news is all about moons of other planets, and here we have Europa, one of the 4 Galilean moons which orbits around Jupiter. And the Galilean moons are basically the 4 biggest moons which were discovered by Galileo Galilei in the 16th or 15th century. This is Europa, and why is this moon actually so interesting? Well, scientists believe that this is the most likely candidate to have life on its surface, or actually under its surface. Now, you may be quite surprised at this, because people have been for a long time have been researching Mars, and they think life over there is most likely, or was most likely. But Europa, in fact, is also a very likely candidate, and probably even more of a better candidate than Mars. Why, you may wonder, why is Europa more interesting? First of all, it's further away from the Sun, and second of all, it's much colder. Third of all, it orbits around Jupiter, which itself is quite radioactive. But Europa is a completely ice-covered ocean, as scientists think. In fact, there is more water on this moon than in the entire planet Earth, which is quite amazing. Now, this crust of ice you see, which also consists of many strange looking cracks, is probably a few kilometers thick, so it will be quite a challenge, first of all, to actually drill through it should we ever send a probe to this moon. Now, secondly, because of the gravitational influence of Jupiter, which actually, well, imagine like this, that it somehow pulls and pushes the inside of Europa, which heats it up. So the inside is probably heating the ocean under this massive ice-cold ice crust. And that is why scientists think that life in there is much more likely than life on Mars. Which is probably a surprise to you watching this video, especially those who asked questions about life on Mars and life on other planets. Because life as we know it, because that is the correct definition of life as we know it, requires water to live in, and it's very likely that on this moon there actually is liquid water. Since there's no short news this week, I'd actually like to go to the questions that have been asked on last week's video. Now, those were very interesting questions. I'd love to answer those. And first question first is coming from JSL Gaming 15 once again. Thank you very much for this question. People have said things like there's water on Mars and there's life on Mars and things like that. Do you think there's life on Mars? Or any other planet even? Maybe there are things just like us somewhere out in the galaxy. Now that is an answer no, that's not an answer. That's a question that I can answer actually pretty easily. Yes, I think there is a very good chance that there is life somewhere out in this universe. Now that may be a controversial thing to say, because it's really difficult to prove there's life and we haven't even seen it. And as you know, I only believe things that have been stated by facts, as I'm some kind of a scientist-like thinker. But since this universe is so huge, there is a very good chance that there's life somewhere out there and we have no idea where it could be. It could be on any of these stars you see in Space Engine. Now, to understand how actually our life is on this planet, we'll have to learn a little bit about circumstances that make life ideal. And for that, I'd like you to teach about the Goldilocks zone, which is around every star in the universe. Let's zoom out so we get a good overview of the solar system, well, at least of the inner planets. As we all know, there's Mercury, Venus, Earth and Mars, the four inner planets of the solar system. If we zoom out any further, we go to the asteroid belt and Jupiter and so on. But these planets are the most important to explain how the Goldilocks zone works. The Goldilocks zone is basically the area around a star in which life as we know it, so life like animals we know, insects and us, is possible to be on a planet. Now within the Goldilocks zone, the temperature is just right for water to be liquid. It's not too hot, so it would be gas. It's not too cold, so it would be ice. Now, of course, there's many more criteria that a planet would have to meet for water to be liquid, like a good atmosphere like Earth has, because Mars has a very thin atmosphere and therefore it's way too cold for water to be liquid. Now, the Goldilocks zone around the Sun has its inner border at the planet Venus, and the outer border is on planet Mars. And that is actually the reason why people think, or scientists think, that life is possible on Mars, or life has been possible on Mars, as there's been plenty of traces of actually there being liquid water, as the, for example, Valles Marineris, which is a oversized Grand Canyon, was most likely formed by erosion, and erosion usually happens through water and wind. liquid water and wind. Now that is actually very interesting, as the same thing happens on Earth, erosion. So yeah, that's basically the Goldilocks zone, and the Goldilocks zone is around every star in the universe, but it depends on the temperature and the size of the star, on how far this zone is from the star. So let's actually pick a random one, like this one is a red giant. That's not a very good example. I'd like to see a red dwarf, actually. Those are only giants. Let's actually go and find, search, and see what we can find. The distance has to be as close as we can get it. A brown dwarf, no, a red dwarf. There we go. Proxima Centauri, the nearest neighbor of the sun. This is a red dwarf. Now it also almost looks like a football or something like that. And a red dwarf is much smaller and much cooler. So that would mean the Goldilocks zone around this star will be way closer to the sun. Otherwise it would get too cold too quickly. Now let's see, check the temperatures of the planets around. This is already a cool ice giant. And its orbit around the star, let's actually look it up. Semi-major axis is the average orbit distance around its star. It's only 2 million kilometers, which is, well, many times closer than Mercury is to the sun. So you can already get a good example of how cool this star is compared to the sun. So the Goldilocks zone will probably even be somewhere within this cool ice giant if the planet had no atmosphere. So let's see what we have, what else we have. Oh, we got a beautiful comet in this solar system. That is really amazing. The planet over here is a cold desert planet, probably no atmosphere either. A cold gas giant, just get far frozen Titan. And there's a gas giant over there, as you can see, with the many moons. Gas giants always have many moons. But here's a good example of how the Goldilocks zone will be much closer to a red dwarf than it would be to the sun. Now let's take the opposite example, a blue star. Blue stars are by far the hottest of them all. Let's actually visit this Oceania, which is basically a planet, as the name suggests, which is completely covered by an ocean. And whether that is water or not, I can't tell. It could very well be water. But let's actually see how far this planet has to be from its star. You can already see the semi-major axis is 43 times further away from its star than the Earth is. And still it's a hot Oceania. The temperature on average is, and I would have to do a quick calculation, over 200 degrees Celsius. So life over there, even so far from its star, would have to be almost impossible, or a very special form of life. And that brings us to the second subject of this question, because we have two definitions of life. The first of all is the definition life as we know it. Life as we know it is basically the life we see on planet Earth. Animals, insects, bacteria, all those things we know and we have discovered. But who is to say that is the only form of life? It could very well be possible that there's very tiny organisms flying around in the atmospheres of gas giants. Let's actually click around on some stars until we find one that has planets which has life. As this space simulator is able... Oh, there we had one. Now I lost it. Darn it. Where is it? There we go. There's another one. Another yellow dwarf, a sun-like star, with two planets that have life. Now this is a very interesting one. This is a gas giant with life. Let's actually visit it. A gas giant, as we all know, is a... Let's turn off the orbits because that's like a mess. As we know, a gas giant is a Jupiter-like planet. And this planet actually has life. It's a temperate gas giant, which means the temperature is just right for life as we know it to be on this planet. However, this is a gas giant, which means no solid surface, but there is a possibility of gaseous water around the surface. The temperature on average is about the same as planet Earth. And the distance of this planet is almost exactly the same as planet Earth is around the sun, which proves that a yellow dwarf has this Goldilocks zone. This one is perfectly in the middle of the Goldilocks zone. At 150 million kilometers, temperature is just right around yellow dwarfs. And therefore probably there is organic multicellular, and multicellular organisms are organisms like we are. Single cellular organisms like how do you call those in English? I'm not very sure. I have to look up a picture about single cellular organisms, which only have one cell, basically. I don't know that much about biology, but that's how it works, kind of. So here we have floaters, which probably means that the organisms living here, whether intelligent or not, that's not to be said, float within the atmosphere of the gas giant. And of course, atmospheres of gas giants are huge. The space engine is unable to get this complete atmosphere, so you'll see this is the bottom, which is of course not the bottom, it's just a very thick gaseous planet. So life could very well be possible on any sort of planet, anywhere within the universe, probably even far within or far outside of the Goldilocks zone. But that would not be life as we know it. It could take on the strangest forms. So yes, I do believe that it is very likely that there is somewhere on some other planet to be life. So thank you very much for this question. It was very interesting to answer it. The second question, or actually a pair of questions, was asked by Dayton Ken, aka 20 Below. Thank you very much for this question, which is also very interesting to talk about. This is a subject of black holes, and his questions were as follows. My question is that if black holes can suck in light, then A. Why is there any visible light left, since there are many black holes? And B. How do astronomers actually find black holes? Now, let me actually turn around those questions, because first of all you need to know how to discover black holes. Because you're right, black holes, as the name suggests, are dark and you cannot see them directly. You can see them though indirectly, but before I'm going to answer that question, let's first have a short lesson about how black holes actually are formed. Black holes are basically the remainder of a very, very old and super massive and giant star. And when that star dies, the inside, the core of the star becomes so compressed that all gravity is pushed and crushed together to one very tiny point, probably a few kilometers in diameter. And all of that gravity together in one point causes so much attraction from all the objects around it that nothing can escape it anymore, not even light. Now, the name is actually pretty confusing because they say it's a black hole, but in fact it isn't a hole in space. Not like there's random gaps in space in which you can disappear and never return from. It's just a very tiny point of well, we're not even sure of what it is made of, but a very tiny point of stuff that has such an extremely and extraordinarily strong gravity pull that nothing can escape it. Like I said, not even light. Now, how do astronomers find black holes? Well, it's pretty hard to find them because, as you can see currently in front of me, is supposed to be a black hole, but you cannot see it because it does not emit light itself. However, when it sucks up any kind of well, space dust or space stuff, it could actually spit it back out, at which point it actually does not emit light itself, but the things and stuff that are being spit out will actually light up, and that is how astronomers find black holes indirectly. They don't see the black hole itself, they see whatever material it sucked up and spat out again. Which the prime example is the supermassive black hole in the center of the Milky Way and pretty much every galaxy, which was not formed by an old star. They are not entirely sure how this supermassive black hole was formed, but it has the mass of a few thousands of stars. And that black hole is actually pretty active. They have been able to get pictures quite a bit from this supermassive black hole, as it sucks up a lot of material around it. In fact, some stars may just orbit so close to it that they get destroyed by the enormous gravitational pull of the supermassive black hole. And on that moment, when that material is being, well, thrown out again, it will light up. Well, the black hole will not light up, but all the material will light up, in which case astronomers are able to indirectly see the black hole. So, now you know how black holes come into existence, now you know how astronomers actually see black holes. But your second question is, why is there any visible light left, since there's so many black holes who suck up the light? Well, sucking up light is not exactly the proper way to say it. In fact, light just completely bends around the black hole. And there's so many stars, far more than there are black holes, that there's always any light left. Black holes do not completely suck it up, they bend it. And to see how that works, I need to slowly and carefully approach this black hole, because we all know how dangerous of a journey it would be to go to such a thing. But this can actually be pretty frightening, as something strange will happen in a moment. We're getting closer as we speak. We're still 250,000 kilometers away, which is very close in astronomical terms. But we're slowly approaching, and something will happen soon. Watch and see what happens. Just look at the stars around the point which is marked, and see what happens with those stars. Especially, let's focus it on this one. Do you see what happens? It is really weird, and you probably wouldn't believe your eyes, but this is gravitational bending or gravitational lensing. Extremely heavy objects have the ability to bend light. You would almost call them light benders. And as you can see, the light of the star behind the black hole is bent in such a way that it's almost orbiting the black hole, and as we get closer, it becomes more and more obvious. On a side note, black holes are not the only objects that can bend light around it or do the gravitational lensing. Really heavy galaxies also do it. I'll show you a few examples of pictures very soon. As we get very close, you see all of the light gets bent around it more and more extreme. It's almost like your eyes are going crazy, and this is probably how it would look like when you approach a black hole. As once again, this is not a hole, but a very tiny object that has enormous gravitational pull. A good example to understand this a little better, how heavy such a small object can be, just hold in your hand 1 cubic centimeter of lead and 1 cubic centimeter of, well, let's say wood, and feel the difference in weight. While they're both the same size, lead is much more compressed and therefore much more heavy. That is a very good example of comparing a black hole to, let's say, a bowling ball in space, which is far less heavy and has a far less gravitational pull than a black hole, who could possibly be the same size as a bowling ball, for example, or possibly the moon. Now, light has gone crazy around this place, as you can see, and when I circle my camera, you can see the Milky Way right in the middle right now. It's completely bended around the black hole, and this is a really very strange thing to see. So that is how light is not completely sucked up, but bent around a black hole. And it does return, as light is not a sort of material that is sucked up and disappears forever. Light is, well, yeah, light is just light. Stars keep emitting light forever and ever until they die. The Milky Way keeps emitting light forever and ever until it disappears. So light pretty much never ends. I hope that answers your question correctly. I've thoroughly once again enjoyed answering this question, because this week we had two very interesting subjects, so thank you very much for that. And this week's place to visit is once again a location which is pretty dark near your own house, because something very special is once again going to happen with two objects in the night sky coming very close together. And this time, not Jupiter and Venus, but Saturn and the Moon. And you have seen Saturn in last week's place to visit, which is quite a coincidence. But on August 31st, at the beginning of the evening, so the current time it is right now, let's actually see, it's 9:20 p.m. local time in pretty close to my hometown. You would probably see Saturn very close to the Moon, on the northern edge of the Moon, which is once again a rare sight. This is how it would probably look like. Saturn as a bright object, and if you had a good telescope or maybe even a binocular, you would be able to see both Saturn and its beautiful rings just right above the crescent moon. But something even more unique will happen if you live in this... What the hell just happened? I did something really weird. Ah, there we go. Oh, I turned time back. Voila, that's a lot better. Sorry about that. Something even more unique will happen when you live in the southeast of the United States and you go outside around this time of day in the evening. Because the moon will actually go over Saturn, which gives an amazing point of view of how big the universe is, because Saturn is so much further away than the moon. Let's actually try and go to the southeast of the United States, like actually try, for example, Florida. Florida. I'm not sure. Yeah, that is pretty much it. Alright, that's good. Where exactly is everything? We'd have to zoom out a bit. Alright, let's speed up time. Just saying that this time that you currently see is the local time of my hometown. I'm not sure how to change it. Let's go to the 31st and speed up time. This is probably somewhere. Oh, it's already September 1st. There, we should have it. This is very strange because they said the moon would cover Saturn. Let's see if we can speed up time here. Well, anyway, it's supposed to happen that the moon will cover Saturn, and which is a pretty rare and unique sight. So if you live in the southeast of the United States, make sure to go outside when there is a bright night, and you might just be able to see this unique opportunity, which is unfortunately not shown in Stellarium, which is very, very strange. But just believe me when I say this, and you can even look it up on the internet, because it is there. And that's it for this week's episode. I hope you enjoyed the news and the big questions that I had the opportunity to answer. I myself thoroughly enjoyed those questions. So make sure to keep asking interesting questions. No question is too stupid or too boring, because I like to teach you guys a lot about space and astronomy, which is, as you all know, my hobby. So keep them questions coming, keep them comments coming, the feedback and the suggestions for any future episodes. Thank you very much for watching, and I hope to see you next week.